Hello, geometry. We are going to start on trigonometry today. Trigonometry is a brand new topic. Nobody in this class has worked with trigonometry yet. So you do need to pay really careful attention because this is going to be all new information. Okay, so trigonometric ratios relate the sides of a right triangle to its angles. It's really the study of right triangles, but you're doing a relationship between the sides and the angles. To write the ratios, we label the sides of the right triangle as the hypotenuse, which you know, the opposite side, and the adjacent side. So, for example, in this picture, the hypotenuse is always the easiest one to identify. So it's always across from the right angle. So wherever you identify the right angle, these all have to be right triangles to do trigonometry. Across from the right angle is the hypotenuse. I'm going to label this guy the hypotenuse. Okay, and then in this picture, we're labeling and referring to angle A. And then we're going to label the opposite side and the adjacent side. Opposite kind of sounds like it is. It's across the triangle or opposite of the angle. So if you look, opposite from this angle A is this side here. So that is going to be the opposite side. We usually just write the word opposite. Okay, once you have the hypotenuse labeled and then draw an arrow, there's the opposite side to angle A. The remaining side is called the adjacent side. Now, adjacent just means next to. So adjacent as a vocabulary word just means next to. Or next door, like it's next door to the angle. So connected here to the angle. So you're going to label the hypotenuse first. Then from whatever angle is labeled, you draw an arrow across, that's your opposite side. And then the remaining side is called adjacent. Okay, connection. Today we will partner this concept with the Pythagorean Theorem. And then tomorrow we will explore how trigonometry connects to similar triangles. Okay, so these are all connected concepts. Okay, label the sides of the triangle below as opposite, adjacent, or hypotenuse with respect to the labeled acute angle. So I want you to do exactly as done in this example for all three of these triangles. So please pause and do that. Okay, welcome back. So right angle, across the right angle here is the hypotenuse. The angle that's labeled across is called the opposite. And then the side that's remaining is the adjacent. Okay, again, across from the right angle is always the hypotenuse. Here's the angle that's labeled, opposite that is the opposite side, and then the other remaining side is adjacent. Last one, so across here is the hypotenuse. I'm going to start abbreviating. Here's the angle that's labeled, and we go across, that is the opposite. And then the remaining side is the adjacent. Okay, trigonometric ratios. So again, these words are brand new. So you have a sine, you have a cosine, and then you have a tangent. You actually may have heard of tangent in language arts before. Going off on a tangent in a discussion just means you're, off topic. But tangent in math means something else. So sine, cosine, and tangent. Now these are strictly just the definitions. There's nothing really to understand about them. It's just these are how the ratios are defined. So the sine of angle A, so you're always going to have an angle here. So the sine of angle A, so let's say we're talking about this guy, is the opposite side divided by the hypotenuse. So you'd say opposite over hypotenuse. So whatever your opposite side length is, divided by the hypotenuse, and that is your sine of that angle. The cosine is defined as adjacent divided by hypotenuse. Okay, so whatever your angle is, you do the adjacent side length divided by the hypotenuse length. Tangent is opposite over adjacent. Sorry, adjacent. Okay, so whatever your angle is, again, you do a ratio of opposite length divided by the adjacent length. Now, there are actually 3 more trigonometric functions. As you can, we're not going to do them. You'll do them 2 years from now. But if you just flip all these fractions, there's 3 more trigonometric functions. We are only going to do these first 3. These are the basics. So there is a nice little way to remember what those are. It's called Sohcahtoa. It's a crazy little word, but every math teacher in America uses this as their memory trick. So Sohcahtoa, I would even encourage you to say it out loud. Sohcahtoa, Sohcahtoa, Sohcahtoa. So what I like to do is rewrite it as so that represents the opposite over hypotenuse. Ka, that represents adjacent over hypotenuse. And then toa represents opposite over adjacent. Okay, and then sometimes I draw this silly little picture. That's water. And then here's a foot, the painted toe nail. And the toe is going into the water. It's a really bad joke, but it's basically you're soaking a toe. So Sohcahtoa. Yep, super silly. Sometimes it helps to help you remember. So Sohcahtoa. Sohcahtoa. All right, so we're going to try some of these. Now, it does depend on which angle you are talking about, so you do have to be very careful. So we're going to start with the angle A. So I'm going to label all of my sides in regards to angle A. So looking at angle A first. Now, the right angle across from the hypotenuse, that is always the hypotenuse. But I'm going to draw myself the opposite over there, and then the side remaining is the adjacent. So looking at Sohcahtoa with angle A, so the ratio or fraction for sine of A would be opposite over hypotenuse, or in other words, 3 over 5. The cosine for angle A is adjacent over hypotenuse. So adjacent over hypotenuse would be 4 over 5. Lastly, the tangent of A, tangent is opposite over adjacent. So from angle A, opposite 3, adjacent 4. So that's going to be 3 over 4. Great. So again, it's nothing to understand. You just have to know these ratios and plug in the number in the correct spot. For angle C, you have to be careful. So I'm going to do angle C in red. So angle C is over here. What you are going to notice is if I draw an arrow to its opposite side, now that 4, AB, is going to be the opposite side. Hypotenuse is still the hypotenuse. And then now this remaining side is adjacent. So it does depend on which angle you're talking about. So if I'm talking about angle C, now this is the opposite, and this is the adjacent. So pause and take a minute to write these fractions. Okay, welcome back. So sine of C, opposite, over hypotenuse. cosine of C, adjacent over hypotenuse. Tangent of C, opposite over adjacent. Okay. Next example. So practice writing trigonometric ratios. First, how do you find the missing side? So this is where the Pythagorean theorem comes in, because notice I only have two sides and I don't know the hypotenuse. But I can find it because I can do the Pythagorean theorem. So we're going to do that very quickly. All right, and then you can use a calculator, but to save time, I'm just going to tell you it is 17. So you could calculate that with a calculator. Add those together, take the square root. It is 17. All right, so now what I want you to do is again pause and try to figure the trig functions for x and for z. Okay, good. So we know the 17 is the hypotenuse, and I'm going to start with x. And I know this is the opposite and this is the adjacent for x. So sine would be 15 over 17, cosine would be 8 over 17, and tangent would be 15 over 8. For angle Z, as I stated, opposite is now going to be on the 8. Adjacent here, hypotenuse is still the hypotenuse. So for angle Z, sine is going to be opposite over hypotenuse. Cosine is going to be adjacent over hypotenuse. Tangent is going to be opposite over adjacent. Okay, last one here we're going to do for trig today. This is a different kind of example. So notice that if the cosine of G, so right away I'm just going to mark G. And I'm going to start labeling the sides. So I know that's hypotenuse. I know this is going to be opposite, and this is going to be adjacent. Okay, and I'm given that the cosine, and the other thing I would do is always write at the top of every page, write Sohcahtoa. So let's write that up at the top. Okay, so I'm given that the cosine of G is 24 over 25. Well, that corresponds to adjacent over hypotenuse. So in this case, I know the adjacent is 24 and the hypotenuse is 25. Okay, now if I want to figure out the sine of G, I am going to have to know the opposite side. So here comes the Pythagorean theorem one more time. So this case, opposite is the 25. So that's your c squared. So I'm going to have a squared plus 24 squared equals 25 squared. Okay, again, you can use a calculator, but you do 625 minus the 576, I believe. So a squared is going to be 49, and then a is equal to 7. Okay, so putting that here, that is going to be 7. So then I can say the sine of G is going to be opposite over hypotenuse, and the tangent of G is going to be opposite over adjacent. Okay, so tomorrow we are going to start the class. These rest of these here you use a calculator for. So you all probably have noticed on calculators it has buttons that say like sin really stands for sine, cos, and tangent. So those are all buttons on scientific calculators. You could probably find them on your phone calculator as well. But this is what those are for. So tomorrow we will learn how to use our calculator to calculate the ratios as decimals. Okay, so that was your introduction into trigonometry, and we will finish this page up tomorrow in class. Good job.